In this video, we'll build on the previous example of the inclined plane, and we're going to complicate our situation a little bit, as if physics wasn't complicated enough. So, in this example, we add essentially another box to our box on the inclined plane. So we need to determine the acceleration of a two-box system as it begins to move. One box with a mass of 1 kilogram that is on the inclined plane, a 45-degree inclined plane, while the other box that has a mass of 5 kilograms is hanging vertically. The two boxes are connected by a string that runs over a pulley. So here's a little sketch of our situation that appears by the magic of my pen. Of course, the first step, as always, will be to draw the free body diagram. So let's start with this box over here, right? What are the forces that are present here? There's, as always, there is the gravity, m2g, and there is the tension because it's connected to a rope, right? There is no normal force because again, it's just hanging in the air. So if it's not touching the surface, there is no normal force. Also, let's label the acceleration as well. The 5 kilogram box is going to push 1 kilogram box up the plane. So it's reasonable to assume that this box is basically going up and this box is moving downwards right here. So acceleration is here. Now on to the second box. So if you haven't watched the previous inclined plane video, I would advise to do it first, but let's take a look. Here we of course have the tension as well, right? Because it's connected to a rope. As always, we always have the gravity that is pointing directly downward to the center of the earth, right? We have the normal force that is at 90 degrees to the surface. So it's at 90 degrees over here. So it's basically pointed right here. And there is no mention of the friction, so therefore we don't have friction, but if we did, it would have been pointed over here. So now that we drew our forces, we need to break down the forces that are at the angle. We need to break them down into components. What I mean by that is that, of course, for this one, right, to the right, the horizontal direction will assume this one and vertical will assume this one. So this mg force, we need to break it down into the x and the y component. We've done this already in the previous example, but just to remind you, right, this y component right here and this x component right here, this angle is equal to this angle right here. So we can solve for our right triangle where our mg is the hypotenuse. So sine of theta, right, is equal to the opposite side, mgx over mg. So mgx is equal to mg sine theta. And cosine theta is equal to the adjacent side mgy over mg, or mgy is equal to mg cosine theta. So essentially, let me just redraw this diagram with those components in mind. So the downward force, right, is going to be mg cosine theta. And the downward force is going to be mg sine theta. So I don't recommend very often to memorize anything in physics, but this inclined plane is so common that I would just memorize these components, right? That perpendicular to the plane is the cosine and down the plane is sine, just so you can save some time when you're setting up these problems. Or at the very least, right, memorize that this angle, right, and this angle are the same. Then you can derive the x and y components. Now that we have completed our first step, which is drawing the free body diagram and breaking down our forces in the components, let's move on to the second step, which is writing the second Newton's law, F net is equal to ma, for each of the objects involved. So just like in the previous video, right, for in the x direction, we'll write it as tension. So tension, let's assume upwards to be a positive direction, right? So tension will be positive minus mg sine theta, right? That is negative because it's down the plane, is equal to m1a, right? So it's definitely accelerating up the plane. There's also the y direction for for this object, which is the normal force upwards, and minus mg cosine theta, which in this case, it's just equal to 0 since the object is not really accelerating, right, up and down. So there's no acceleration. So this is just F net, right, is equal to ma. And of course, now we also need to write down the second Newton's law for this object right here. Now, what do you think the net force is going to be for this object, right? If you take a look at the free body diagram. So hopefully you said that it's going to be tension, right, minus m2g, assuming that up is a positive direction and down is a negative direction. Now, of course, it will be accelerating, but notice that acceleration is downwards. So it's actually going to be negative m2a, right? Because acceleration is a vector. So just like any vector, it can be positive or negative. Great. Now, in this case, we're actually not going to be needing this equation right here, right? Because what we're solving for is acceleration, and there's no acceleration here. However, if the problem had friction in it, we would need this as well. So I still advise to always set it up. So having these two equations in mind, we have essentially two unknowns, right? We have the tension, that is the unknown, and the acceleration, right? Two blocks are accelerating together, so they have the same acceleration, and they're tied over the same string, so they have the same tension. Okay, since we're trying to solve for acceleration, let me just rearrange this equation over here for tension. So I'll add mg sine theta to both sides. And let me plug that in for this tension over here. So instead of t minus m2g, it becomes m1g sine theta plus m1a. So this is instead of this term t minus m2g is equal to negative m2a. Now, the rest of this is just going to be algebra, right? So let me put this term right on the right side, because again, I'm solving for a. So I want to put all of my a terms together, right? So I put this term on the left hand side, and I can also put now these terms on the left hand side. So over here, so subtract this, right? And also add this side over here. So, oops. So add m2g to both sides. Now I only have terms with a on the left hand side, so I can factor them out and divide by this parenthesis on both sides. So a final answer is going to be m2g minus m1g sine theta over m1 plus m2, right? Or if I plug in for all the unknowns, right, where m2, I remember was 5 kilograms, so 5 times 9.8 minus m1 was 1 kilogram times 9.8 times sine of 45 over 1 plus 5. All of that should be equal to 7.01 if you plug it into your calculator, meters per second squared. So as you can see, nothing scary in this problem, right? Even though we just complicated this a little bit by adding another box, the overall process stayed the same, right? Draw the free body diagram, set up the second Newton's law, and plug in everything to solve for our unknown. Guys, keep practicing, keep watching these videos. You can do it. You can conquer physics. Keep practicing on your way to an A. Thank you for watching.